Today's notes are going to be on increasing and decreasing functions. And as soon as we see these words increasing and decreasing, the first thing that we want to start thinking about is the word slope. So we're talking about, is the slope increasing or is the slope decreasing? Now, before we talk about that, just a quick side note. Just remember, in math, we always read graphs, just like in English, from left to right. And when we think about left and right, we're thinking about our x values. Now, when we talk about increasing and decreasing, that's actually asking what is the y value doing as we move from left to right. So if we notice in this first graph, as I move to the right on the graph, my y value is going up, meaning it's increasing. Again, as we move from left to right over here, our y value is going up. Again, that means it's increasing. You never really think of x as increasing or decreasing. It's just as we go left to right, what is our y value doing? Our y value is getting higher, so that means that this graph is increasing. So lots of other ways to think about increasing is that our slope, right, is positive. Or instead of using the word slope, in calculus, we're going to say that our derivative, f prime of x, is positive. And another way you'll see this written, instead of it's writing out positive, we'll see that f prime of x is greater than 0. And when that happens, when our derivative is greater than 0, right, greater than 0 meaning it's a positive number, then we're going to have a graph that looks somewhat like one of these, where we have it increasing. It's an increasing graph. Similarly, for decreasing, as we move from left to right, if our y value gets smaller, it's going down, then we have a So similarly, when a graph is decreasing, that means that the slope of that graph is going to be negative. And another way to write that, instead of slope, we're going to say that the derivative is negative, or the derivative is less than 0. So whenever you see a derivative that's negative, that means that graph is decreasing. The slope is negative. The graph is kind of, the y value is going down. And when a graph has a derivative that's positive, we know that it's increasing. The graph is going up. So let's do an example. This one says, 1 is the curve y equals x cubed plus x squared minus 8x plus 5, increasing and decreasing. So we want to kind of remember back to these situations that increasing and decreasing are going to happen when the derivative is positive and when the derivative is negative. So just a side note, what happens when the derivative is 0? Well, if it's increasing when it's greater than 0 and decreasing when it's less than 0, when the derivative is 0, it's not really increasing or decreasing. This is what we call a horizontal tangent, right? So at a horizontal tangent, at this point right here at the bottom of our graph, right, our graph right there is not increasing or decreasing. It just stopped decreasing and it's changing to become increasing. But right there, it's not going up or down. So when our derivative is equal to 0, it's neither increasing nor decreasing. And we're going to have another name for that later on. Anyways, in order to figure out those spots where our graph is increasing and is decreasing, we actually need to know when is our derivative equal to 0, so we can kind of find those ranges when it's positive and negative. So when does it switch between increasing and decreasing? And the way that we do that is that we're going to take the derivative. So we take y prime, which will be here at 3x squared plus 2x minus 8, and we're going to set that equal to 0. So we're going to find out where is that graph at those spots where it's neither increasing nor decreasing. So in this case, we're going to have to factor this. You can do your x method. I'm just going to say that when we factor this, we get 3x minus 4 and x plus 2. And that's equal to 0. And I think with your x method, I think it would be negative 24 and 2. and then numbers that multiply to negative 24 and add up to 2 would be negative 4 and 6, and then we can divide out on the 6 side since we have a coefficient of and so once we divide out the 3, then we'll get 3x minus 4, we divide out the 3 there, times x plus 2. Now, each of these, we set both of those cases 3x minus 4 equal to 0, x plus 2 equal to 0, and we get x equals 4/3 and x equals negative 2. So these are the spots, both of these are where the derivative f prime of x equals 0. So we know that at those spots the derivative is equal to 0. What I like to do with these is I always like to make it's called kind of a number line analysis. And the way we do a number line analysis is we just make a number line. Now, in order to get credit on the AP test, you need to tell what you're doing an analysis of. So this one's an analysis of y prime. And on my number line, these are the critical points we need to put. So we're going to make sure we have negative 2 on that number line and 4/3 on that number line. And I know that here at these 2 points, my derivative is 0. But I want to figure out what is it in between in these ranges, right? Less than negative 2, in between negative 2 and 4/3, and greater than 4/3. So we just plug in numbers. I'm going to plug in a number smaller than negative 2. So these are like test points. So let's test out negative 3, for example. And I like to, we're going to plug in negative 3 into the derivative into y prime. And I like to actually plug it in where it was factored. So into this line here, where it's factored. You could plug it into the original, but I find it easier to plug in where it's factored. So when I plug in negative 3, I get 3 times negative 3 is negative 9 minus 4 is negative 13 times negative 3 plus 2 is negative 1. That's a positive number. I don't even care what the number is. I just care, is it positive or is it negative? Well, I know it's positive. Negative times a negative is positive. Now I'm going to plug in the number in this range. I'm going to plug in 0. Okay, when I plug in 0 here, we get negative 4. Right, 3 times 0 minus 4 is negative 4. Times 0 plus 2 is 2. Negative 4 times 2 is a negative number, negative 8. Again, I don't care that it's negative 8, I just care that it's negative. And then I'm going to pick a number bigger than 4/3, let's pick 2. And when I go back in and I plug it in, 3 times 2 is 6, minus 4 is 2, so that's a positive number. Times 2 plus 2 is 4. Again, a positive number. 2 times 4 is 8, which is again positive. So from this analysis, we can say that our graph is increasing from negative infinity to negative 2 union 4/3 to infinity. And the reason that we put parentheses there and not brackets there is because the derivative is 0 here. So it's no longer increasing at negative 2. So it increases up to negative 2, but it doesn't include negative 2. And then our graph is decreasing from negative 2 to 4/3. And if an AP test asked you to justify your reasoning, you'd say, you'd show this number line and say kind of, because f prime of x is positive from negative infinity to negative 2 and 4/3 to infinity, and f prime of x is negative from negative 2 to 4/3. So again, this right here, this part right here would be if a question asks you to like justify, explain your reasoning, then you would add that part on right there. So that's increasing and decreasing in a nutshell, and we have one more video tonight.